Good morning, children. Welcome you all back to the science class. Let us have a small recap of what we learnt before we go into today's learning. In the previous class, we learnt about inertia. What is inertia? The inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced by an external unbalanced force. Then we learnt about linear momentum. What is linear momentum? The product of mass and velocity of a moving body gives the magnitude of linear momentum. And the formula for linear momentum is P is equal to m into v, that is mass into velocity, where the unit for mass is kilogram and for velocity it is meter per second. Next we learnt about Newton's first law of motion. Newton's first law states every body continues to be in the state of rest or uniform motion along a straight line unless it is acted upon by some external force. So Newton's first law gives the definition of inertia and also the force. And next we learnt about moment of force. So moment of force is nothing but the rotating or turning effect of a force about a fixed point or fixed axis is called moment of force or torque. And the formula for moment of force or torque is denoted by the letter τ, which is equal to force into perpendicular distance. So for force it is Newton, for distance it is meter. So the unit for torque is Newton meter. Today we are going to learn about principle of moments. When a number of like or unlike parallel forces acts on a rigid body, then the algebraic sum of the moments in the clockwise is equal to the algebraic sum of the moments in the anti-clockwise direction. Consider a rigid body. A rod has 2 points, say A and B. Consider a point P on the rod. Consider the distance d1b between A and P and d2b between B and P, and the two forces F1 and F2 are acting at A and B. The force F1 is acting along this direction, so it is in anti-clockwise direction, and the force F2 is acting along this direction, so it is clockwise direction. According to principle of moments, moment in clockwise direction is equal to moment in anti-clockwise direction. So what is the formula for moment of force? Moment of force is nothing but force into distance. So the moment in clockwise direction will be F1 into D1 is equal to moment in anti-clockwise direction, which is F2 into D2. So the moment in clockwise direction is equal to moment in anti-clockwise direction. Next, let us learn about Newton's second law of motion. According to this law, the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. So according to this law, the force is directly proportional to the rate of change of linear momentum. Since this law is used to measure the amount of force, this law is also called as law of force. Let m be the mass of the body moving along a straight line with the initial speed u. After the time t, the change in velocity be v due to the unbalanced external force. The initial momentum of the body Pi is equal to m into u. The final momentum of the body Pf is equal to m into v, which is the final velocity. So the change in momentum will be del p. The change in momentum is denoted by del p, which is equal to final momentum minus initial momentum. That is nothing but mv minus mu. According to Newton's second law of motion, force is directly proportional to rate of change of momentum. That is, force is directly proportional to change in momentum by time. Rate of change of means change in momentum by time. So F is directly proportional to a change in momentum is mv minus mu by time. When we remove the proportional sign, we have to write the constants, which is equal to k mv minus mu by t, where k is equal to 1 in all system of units. So it becomes F is equal to m is common, so we can take it out, m v minus u by t, where v minus u by t is nothing but acceleration, that is change in velocity by time. So force is equal to mass into acceleration. From this we know that force is required to produce the acceleration of the body. In uniform circular motion, even though the speed is constant, the direction of velocity changes at every point on the circular path. If it goes straight, it cannot go in a circular path. And the acceleration is produced along the radius. So the acceleration produced along the radius is called as centripetal acceleration. And the force which produces an acceleration is called as centripetal force. Now what is the unit of force? The SI unit of force is Newton, and in CG system its unit is dyne. Next, the definition of 1 Newton. The amount of force required for a body of mass 1 kilogram produces an acceleration of 1 meter per second square. That is, force is equal to mass into acceleration. If we say mass is equal to 1 kilogram and acceleration is equal to 1 ms minus 2, then force is equal to 1 kilogram ms minus 2, or we can say it is 1 Newton. Next, the definition of 1 dyne. The amount of force required for a body of mass 1 gram produces an acceleration of 1 centimeter s minus 2. That is, 1 dyne is equal to 1 gram centimeter s minus 2. Next, let us learn about impulse. What is impulsive force? A large force acting for a very short interval of time is called impulsive force. Next, let us see the examples of impulsive force. Falling down the glass to the floor. Hitting a nail using a hammer. When a force acts on a body for a period of time, then the product of force and time is known as impulse. An impulse is represented by the letter J. So J is equal to force into time. But according to Newton's second law of motion, force is nothing but change in momentum by time. Okay, so we substitute here. So change in momentum by time into t. So tt get cancelled. So the impulse is equal to del p, that is change in momentum. Then unit can be written as kilogram meter per second, or we can write it as Newton second. We can see the examples of impulse. Automobiles are fitted with springs and shock absorbers to reduce jerks while moving on uneven roads. In cricket, fielder pulls back his hands while catching the ball. He experiences a smaller force for a longer interval of time to catch the ball, resulting in a lesser impulse on his hands. Now let's learn about Newton's third law of motion. That is, for every action there is an equal and opposite reaction. When a body A applies a force on a body B, so FA be the force applied by the body A, and the body B reacts with the force FB on A. So according to Newton's third law, For every action there is an opposite reaction. So FB is equal to minus of FA. Now let's see some of the examples of Newton's third law of motion. When birds fly, they push the air downwards with their wings and the air pushes the bird upwards. When a person swims, he pushes the water using the hands backwards and the water pushes the swimmer in the forward direction. When you fire a bullet, the gun recoils backward and the bullet is moving forward, and the gun equalizes this forward action by moving backward. Next, let us learn about law of conservation of linear momentum. To prove the law of conservation of linear momentum, let us consider two bodies A and B of masses m1 and m2 moving with the velocities u1 and u2 in a straight line. Let the velocity of the first body be greater than that of the second body. That is, u1 will be greater than u2. During an interval of time t second, they tend to have a collision. After the impact, both of them move along a straight line with the velocities v1 and v2. Now force on body B due to AB, FB is equal to m2 v2 minus u2 by t, and force on body A due to BB, FA is equal to m1 into v1 minus u1 by t. By Newton's third law of motion, the action force will be equal to reaction force. That is, FA is equal to minus of FB. That is nothing but, FA is nothing but m1 v1 minus u1 by t is equal to minus of m2 v2 minus u2 by t. Now t gets cancelled, multiply this, so it becomes m1 v1 minus m1 u1 is equal to minus of m2 v2 plus m2 u2. So we can write m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. The above equation confirms, in the absence of external force, the algebraic sum of the momentum after collision is equal to the algebraic sum of the momentum before collision. Hence, the law of conservation of linear momentum is proved. Next, let us see about rocket propulsion. Propulsion of rockets is based on the law of conservation of linear momentum as well as Newton's third law of motion. Rockets are filled with a fuel, either liquid or solid, in a propellant tank. When the rocket is fired, this fuel is burnt and the hot gas is ejected with a high speed from the nozzle of the rocket, producing a huge momentum. Force is produced in the combustion chamber, which makes the rocket project forward. While in motion, the mass of the rocket gradually decreases until the fuel is completely burnt out. Since there is no external force acting on it, the linear momentum of the system is conserved. The mass of the rocket decreases with altitude, which results in the gradual increase in velocity of the rocket. At one stage, it reaches a velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. Thank you, children. Just go through the lesson. We'll see you in the next class.